In this presentation, two methods, statistical methods, will be compared: the factor analysis and the principal component analysis. Factor analysis and principal component analysis are related. They are similar. However, both are not identical. Both are statistical multivariate analysis methods aim to reduce the dimensionality of the data. That is the common things between these two methods, abbreviated as PCA and FA. PCA is merely mathematical technique or method that aims to reduce the data dimensionality, i.e. reducing the number of items. It is frequently used in survey and questionnaire analysis to reduce the large number of items or questions through the method of principal component analysis. Factor analysis, on the other hand, is designed to identify unobservable factors from observed variable. It aims to identify latent factors that explain the correlations between observed variables. So there is a subtle difference between PCA and FA. PCA is a data reduction techniques, reduce the number of items. FA is designed to look for latent factors. So both have different approaches and assumptions. Choosing which one to use, whether PCA or FA, depend on the underlying assumptions of the data and the objective from the research study. PCA is merely dimensionality reduction technique. It aims to group set of variables or items or questions from a survey or questionnaire into a new set of uncorrelated variables called principal component. That is the main target of or objective of performing PCA, to generate principal component, group these set of or collection of variables into component. These components retain maximum variance in the data. However, the FA is a method to identify latent factors that underlie observed variables in data. Its aim to explain correlations between observed variable via number of underlying and unobserved factors. So there is a major difference between both these techniques. The first one is reduction technique. The second one, search for latent factor. This latent factor will explain correlation between variables when they are arranged into factors or constructs. In terms of assumptions, PCA assumes that principal component generated are linear combination of the original variables, and these components retain or explain the maximum variances in the data. The FA assumes that the observed variables are affected by underlying latent factors. Those observed variables have a unique variance that is not explained by the factors. So FA will look for common factors and unique factors. In terms of the interpretation, the PCA, the principal component or components generated or obtained from the analysis, do not have an interpretation in terms of the original variables. They are mathematical constructs. So these components are mathematical constructs representing variance in the data. For the FA, the factors extracted from the factor analysis are intended to have a meaningful interpretation in terms of the observed variable. Each factor is associated with a subset of observed variable that have high loading on that factor, indicating a strong relationship. So in FA, a construct is generated or factors are produced. Those produced factors have a meaning as they have in them items or variables that measure that construct or factor. In terms of variance explanation, the PCA aims to explain maximum variance in a data by producing a principal component. The first principal component explains the most variance. The second one explains the second most, and so on. In FA, the focus of the factor analysis is not on explaining the variance, but rather than that is to identify the underlying factors that can explain the correlation between the variables within that factor. For rotations, PCA, the principal components produced are orthogonal to each other, meaning they are not correlated. In FA, factor loading are not necessarily orthogonal, and different methods of rotation such as Varimax, Promax can be applied to make the factors more interpretable. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, R-Statistic, or Statistics, GraphPad, Prism, GPower, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R-Statistics, GraphPad, Prism, Mann, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.